So here's a demonstration of what actually gets transmitted from the Raspberry Pi to the host. And so we have these different terminals here. On the right, the Ubuntu terminal, the purple is going to be what we actually see from the Raspberry Pi. I'm remoted in right now over SSH. And then the blue terminal is the file that we watch on the host. And then this command prompt window is going to be what we see from our script running on the host to actually listen on the port. So here I've started it, and now it will usually say device or resource busy when the actual Bluetooth daemon is running, but I've killed that for now just so we can watch what happens. So I've started it, and it's waiting for a connection. So if I go ahead and run the script on the host, we wait for our port, we've secured the connection, and we're transmitting. This is what's actually getting sent, the encrypted payload, and then once it's decoded, our actual data. So, and now suppose that we were to lose connection and the transmission was to stop. So I'll just kill this terminal. We are waiting for the host again. So suppose the drone goes out of range or something happens on the laptop, then it will just wait again. And then we restart it, and it resecures the connection and start transmitting once again. And so when I roll the drone to the right, you can see those values are updating to the left. So there we go. You'll notice to stop my lateral movement, I pitch hard down, and that Bluetooth delay reconnect brings that -50 up just a couple seconds after. And then just to show the live updates, not every degree gets captured, but I start to spin just so we see the yaw will change dramatically as I rotate the drone around. So going over the code for this project, what we have here on the left and right sides are what's on the host on the left side and what's on the Raspberry Pi on the right. And so the way that I push everything from my workstation to the Raspberry Pi is usually through secure copy, and it just goes to the source file, and that's where we run everything off of. In this case, I have a Project 9 folder, and then that's where all of this stuff lives. So I have the Project 9 Python file is what runs on the Pi, and it's taking it takes from the previous projects where we get the GPS and we get the accelerometer data. And so because of that, and I've tried to make this as robust as possible, in this case, I'm just loading in those files, and those are going to be used. In this case, it's the LLA file, and I've stored everything inside of an .ini. So in this case, this is where my previous data lives, and I chose to go with encryption to kind of go beyond a little bit of what was asked for in the project, because so we talked about during office hours, but I'll get to that a little bit later. So we have our main file here, and so we're pulling in our configurations from that INI, our Mac, the channel we're going to talk through, and our data. Now, I should talk about the setup here a little bit. So after getting BlueZ working on the Raspberry Pi, I had to set up a like a port server running on the Pi, so that way when there is a connection from my Windows machine to the Raspberry Pi, it reads a port, and in this case, port 4. It's on my Windows 11 laptop. It shows as channel 4 or COM 4. In this case, we're just transmitting on 4. So the main purpose of this script is just to load everything in. And if we have an encryption key, then we're going to send everything encrypted. And I have this connection object that I made. And I'll go through that in a sec. So once we get the connection object, then we can actually read from our file that we've got our data in, and then send it. And the connection will actually handle making the encryption, and then like just handling that connection, whether it drops off or stays up. Okay, so talking about that connection object, and what happens here is it tries to make the connection. When it does, it will just store that socket. Otherwise, we await the connection. And so this await connection is very important because depending on the kinds of errors we get, it could just mean that our machine just isn't listening on that port. So COM4 might not be open right now. And that's because usually host is not running. So while it's not running, it's going to just sleep and try again. And that's why in our connect, this is while we're not connected. And when we're transmitting or when something happens and we lose connection, our transmitting variable gets turned off, and then we just keep trying to get the connection back. So that's very helpful when the drone goes out of range, or you're trying to debug your host file, and you turn it off and turn it back on. This way you don't have to restart the Bluetooth connection every time. Okay, so once we do have our everything in order, this transmit will encrypt the data and send it off. And there's some encoding that has to be done, and that's just to make sure that we're using bytes and not strings. It's very important that when you send your data over the socket, it's actually got a new line, because you might see over here on the host, the serial connection is trying to read the line. And so if there's never a new line character, it's never going to finish reading the line. And so especially when you encrypt the data, you might have a new line, but that gets kind of annihilated by this by the encryption. So sending a new line, and then that will just have a plain text new line character, but your message will still be encrypted. So that seems to work fine. Now, talking about the encryption, I did need some help trying to understand how this process will work, because I didn't understand initialization vectors, but I can tell you now what these are. And so let me do that. What we have going on here is we get our plain text in, and the string is usually, it's going to be base 64 or UTF-8. What the point behind this is, we have some secret key, and you saw this in my INI file. This is the key, and it's generated with OS. And so what you do with this is you have our plain text, and essentially OS urandom, this is how we generated the key in the first place. And this initialization vector, also known as a nonce, it is essentially, it makes sure that the transmissions are pretty random every single time. Otherwise, you might have the same message being sent twice, and it would look the same both times. So that would be pretty easy if you knew what that message was, to be able to then decrypt things. So the initialization vector is just random, that sends that randomizes it a bit. So now that we have our initialization vector, we have to create the cipher, which, based on what kind of cryptographic algorithm you're using. In this case, I'm using AES base 16, which is very easy and rudimentary, but it was mostly just a proof of concept to show that this would work and it's repeatable. So using that, we encrypt the payload and we got to encode it so that we can actually add our payload. And then we have to add our initialization vector to the beginning of our encrypted message. So that way, when we get our entire payload, we can slice off our nonce, our initialization vector, and use that as part of the decryption. We encode it so that way we can transmit. And that's what we do here. Now, in order to send all this to the Raspberry Pi and have it run on startup, we have our daemon, which every time this gets run after pushing to the Raspberry Pi with secure copy or whatever method you choose, this can just stop the previous service and then start it up again and make sure it's working. And then this is the actual service that gets copied and moved on the host side of things. Here is our decryption, but we'll get to that in a sec. First, we start up by loading in all of our host configurations. And in this case, I have my the file that I'm going to write all of this to is this Bluetooth LLA file, which I just watch with WSL. And here's our same encryption key. And we got our port and our baud rate. Here's an example of what that looks like with no data in it. It's just all zeros for now, but it will populate when it actually runs. And then when we have our configurations loaded in, we create our serial object. And while we can read lines, and this will block everything else until we actually read a line. So just be aware of that. We get our the raw bytes, and then we got to take off that new line at the end and decrypt our data. And it's essentially the same thing in reverse. We base 64 decode, slice off our initialization vector. This is the rest of it's our encrypted text. And then we know that we have the AES cipher algorithm that we're going to use. We decrypt it and then decode the UTF-8. So because I'm sending this to the Bluetooth file and I'm parsing it, I have these begin and end statements just to show when to actually write the whole payload to the file. And the main reason I do that is just so the file, as I'm watching it, isn't updating constantly, or it doesn't have just a like a one line in there, and it writes and then clears it, writes, and so that tends to make it flicker a lot. So I just have it write the entire file contents.